We discover the problem, the easier and less expensive is to correct it. The longer the delay in discovering problem, the higher is the cost. Therefore, it makes sense to control the situation where the work is done, that is at the most upstream operation, if not at the product design stage, shows the effect of on cost shows the effect on cost to the company due to the defect identified at different stages of manufacture. The increase in cost due to delayed identification of the defect is on count of added cost element. Defects found on process very little, as we have seen in diagram. Next process some cost of delay. Then next end of line significant rework. Elements of cost rework rescheduling. Final inspection very high significant rework, delay in delivery, added inspection, customer end excessive, warranty cost, complaint handling, loss of reputation, loss of customer, loss of market share. Type of error, description of error, typical examples, remedial actions are given. Nine types of error given. You can see on our PPT. There examples and solutions means remedial action also given. From the above, we can conclude that mistake occur due to many reasons. Almost all mistakes can be avoided by systematic identification and analysis of mistakes. The solution lies in the developing a prevention mechanism, which Japanese called Poka-yoke. Causal relationship between type of defects and human error. The causal relationship between types of defects and human error. Types of defect: omitted processing. Human errors commonly responsible for the defect: forgetfulness, error of amateurs, willful errors, inadvertent errors, wrong processing, error of amateurs, willful errors, inadvertent errors, judgmental errors, errors in setting up workpieces, forgetfulness, inadvertent errors, missing parts, willful errors, inadvertent errors, wrong parts, forgetfulness, misunderstanding, mistaken identity, errors by amateurs, then processing of wrong parts, misunderstanding, inadvertent errors, misoperations, inadvertent errors, improper equipment, forgetfulness, inadvertent errors, improper use of jigs and fixtures, inadvertent errors, improper operations of the machine, errors of amateurs, inadvertent errors, unexpected errors. Poka-yoke device. Poka-yoke may be designed either to help the operator to recognize the defect before it is about to occur called prevention type POCA yoke, or to help the operator to know immediately on occurrence of the defect called detection type POCA yoke. Some of the POCA yoke devices which can help to avoid defects are guide pins, locators, error detection buzzers, alarms and blinking lights, limit switches, counters, color coding, checklist. SMED, single minute exchange of die, is a technique of performing a setup operation that is effecting a machinery setup for a changeover from job to another, one job to another, is lesser amount of time in that is in fewer than 10 minutes expressed as single digit. The benefits of SMED include reduced work in progress, better average daily production, increased capacity to meet customers' demand and faster delivery to customers. TPM, total productive maintenance, is keeping machine in good working condition through systematic maintenance of equipment so that they fail less frequently or production process they support continue without interruptions. GIT, just in time. This is a management philosophy aimed to eliminate waste from every aspect of manufacturing and its related activities. The term GIT refers to producing only what is needed when it is needed and in just the quantity needed. JIT is a full-through production scheduling and inventory control system that ensures a well-timed flow of units from suppliers into a production area, hence onto a and down a production line, and finally into packaging, dispatch onto the point of sale. JIT eliminates non-value added activities, reduces expensive stocks, and ensures availability of required materials just prior to its use, achieved by either expensive computer programs or by use of inexpensive manual control system in the form of cards. Quality circle. It is a collective effort where 7 to 15 volunteers from the workers form a group and meet regularly, weekly or bi-weekly for about an hour in order to identify, analyze, search for solutions to work related problems and the ways of implementing the solution. The meetings, which are generally supervised, addresses themselves to technical problems and follow a strict problem solving approach. The problems are not limited to a quality alone, but can be related to any function such as improving housekeeping and work environment, dealing with technical problems that affect productivity. Quality circle should encourage participation by all members and should foster creativity. The success of quality circles in Japan are striking. The quality circles can be effective here or elsewhere also if the management commitment to the basic philosophies underlying the concept of quality circle is there. In India, BHEL started its first quality circle in at its Hyderabad unit in 1981. The idea caught in the entire corporation in 2 years, and there were more than 200 circles with about 1800 members. Other companies also immediately followed suit, but the quality circles cannot immediately be imposed on any unit and expect to yield result. It should be implemented gradually with building with appropriate work culture. The Quality Circle Forum of India has been active in propagation of the knowledge gained from experience about methodology for starting and establishing quality circles in the environment.